Assalamualaikum, my name is Hanim Maisara and I will be talking about the meaning of differentiation. So differentiation is a method of finding the derivative of a function where we find the instantaneous rate of change of a function with respect to one of its variables, which is equivalent to finding the gradient of a curve at any given point. This concept is used to determine things like velocity from a position function or to find the maximum and minimum values of a function. So basically, differentiation is a way to find how fast something is changing at a specific moment that tells us the slope or steepness of a curve at any point. We use differentiation to find speed from a position graph and find highest or lowest values of a function. So if the graph goes up, then it's positive derivative. If the graph goes down, it's negative derivative. But if the graph is flat, then derivative is equal to 0.
There are many rules of differentiation, including power rule, product rule, quotient rule, chain rule, implicit differentiation, and linear approximation.
For implicit differentiation, we are going to use the first principle formula. So the question is fx equals to x squared. And then the formula of the first principle is fx equals to limits h approaches 0, fx plus h minus fx divided h. So first we substitute x squared into the formula, and then we expand the x plus h squared. After we expand it, we cancel out the x squared. Then we got fx equals to limits h approaches 0 to xh plus h square divided h. And then we cancel out the h, then the final answer is fx equals to 2x.
Okay, so the second subtopic is the derivatives of trigo, exponential and logarithmic function. The question given is ln sin 6x cubed plus 6 exponent to the power of 3x cos 5x per 3. So the first thing I'm going to do is to differentiate the function ln sin 6x cubed, which we're going to get 1 per sin 6x cubed times the differentiate of sin 6x cubed, which we're going to get cos 6x cubed, times the differentiate of 6x cubed, which we're going to get 18x squared, plus 1 per 3 in bracket the differentiate of the function 6 exponent to the power of 3x cos 5x, but we're not going to differentiate it right away because there's two different functions here, which is 6 exponent to the power of 3x and cos 5x. So we need to use the product rule, which is uv prime plus vu prime. So we need to let 6 exponent to the power of 3x equal to u and cos 5x equal to v. So we're going to get 6 exponent to the power of 3x times negative sin 5x times 5 plus cos 5x times 6 exponent to the power of 3x times 3. So we're going to simplify it all, and we're going to get 18x squared cos 6x cubed per sin 6x cubed plus 1 per 3 in bracket negative 30 exponent to the power of 3x sin 5x plus 18 exponent to the power of 3x cos 5x. So here we have cos per sines, which we know it is equal to cot, so we're going to simplify it again. So we're going to get 18x squared cot 6x cubed plus in bracket negative 10 exponent to the power of 3x since 5x plus 6 exponent to the power of 3x cos 5x. So the final answer is 18x squared cot 6x cubed minus 10 exponent to the power of 3x since 5x plus 6 exponent to the power of 3x cos 5x. So that's all. Thank you.
The next topic is chain rule. First of all, I will tell you what is the use of chain rule. Chain rule is used whenever we need to differentiate a composite function that has outer and inner function. For more understanding, let's do equation. The equation given is y equal to ln in bracket 4x plus exponent power of 2cx. So first, we let u is equal to 4x plus exponent power of 2cx. So y equal to ln u. Next, we differentiate all the function after y equal to ln into 1 over x. the differentiate of 4x plus e power of 2 sin x is equal to 4 plus e power of 2 sin x. For exponent power of 2 sin x, we need to differentiate, which become 2 cos x. So next, we write the general equation, which is dy over dx is equal to dy over du multiply du over dx. So our dy du is 1 over x, which is line, and our du dx is 4 plus exponent power of 2 sin x and 2 cos x. First, we multiply our du dx, which become 4 plus 2 exponent power of 2 sin x cos x. So for 1 over u, we insert u, which is 4x plus exponent power of 2 sin x. So it become 1 over 4x plus exponent power of 2 sin x. Then we multiply dy over du and du over dx. Then we got the answer. That's all.
Next subtopic is implicit differentiation. So the question is x squared plus xy plus y squared equals to 10. So for x squared, we bring the power of 2 to the front and subtract the constant. For xy, we use the product rule, which is u v prime plus vu prime. So our u is x, our v prime is we differentiate the y, it becomes dy dx, plus our v is y, and our u prime is we differentiate the x, we got dx dx, so it equals to 1. Then we differentiate the y square, so the derivative is 2y times dy dx because y changes with x, then equals to 0. Then we factorize the equation and we bring the dy dx to the front, and we put x plus 2y in the bracket and equals to negative y square minus 2x. Then we got the dy dx equals to negative y square minus 2x divide x plus 2y.
Okay, so the last subtopic will be the linear approximation and differentials. So the question given is cube root 3 times 10.09 to the power of 5 plus 3 per cube root 10.09. So the first step, we're going to let 10.09 equal to x, and we're going to get fx equal to 3x to the power of 5 by 3 plus 3x to the power of negative 1 by 3. The second step is we're going to differentiate the function, which we're going to get f prime x equal to 5x to the power of 2 by 3 minus x to the power of negative 4 by 3. The third step is we're going to find delta x using the formula delta x equal to x minus x naught, which we're going to get delta x equal to 0.09. The last step, we're going to find the approximate value of fx using the formula fx approximate to fx naught plus f prime x naught times delta x, which is we're going to get the last answer, which is 69.05. That's all.
In conclusion, Chapter 2 strengthens our understanding of how functions change by introducing key differentiation technique. We learn to differentiate algebraic, trigonometric, exponent, and logarithmic function. We also apply the chain rule to composite function, use implicit differentiation for complex equation, and apply linear approximation to estimate values. Together, this skill build a strong foundation for solving real mathematical and real-world problems. Thank you.